Okay. Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon to all of you. So we meet again in week 4 of the semester. Okay, so today we will continue the class. Okay, anyway, thank you for those who have emailed to me your assignment. There are like 4 or 5 groups that have already emailed to me. Okay. Some of them I've already replied, some not yet. Okay, because I've just received just now, a few minutes just now. Okay. Okay, so we start our class for today. Okay, so you can see my slide here. Can you guys see my presentation?
No, doctor.
No, doctor.
Huh?
No.
Lupa tekan present. Okay, sorry, I forgot to click the presentation. Sorry. Okay, this one. Okay, this one. Can you see this?
Yes, doctor.
Yes, doctor. Now we can see.
Okay, sorry. Okay, so today we will still continue the same chapter, chapter 1, linear algebraic equations. So last 2 weeks we have seen 2 methods, direct and indirect methods to solve linear algebra equations, right? So that was Jordan, Gauss, Jordan, and Jacobi. Okay, and direct iterative methods, right? Okay, so there are some more. Actually, there are a lot more. So today I will introduce another 2, okay, methods to solve linear algebraic equations. Okay, okay, so we start. Okay, so that's why I named these slides as chapter 1B, so second part, okay? Okay, so the first method is called LU decomposition. Okay, it's just named as LU because lower upper triangular matrix. Okay, so the linear algebra equation are written in terms of a matrix. Okay, so LU decomposition is it's like we decompose, okay, divide, okay, or factorize, something like that, the matrix A into 2 triangular matrix, okay, that we call lower and upper. Okay, and then after we produce, means that we have to reproduce the matrix A in terms of L and U matrix, the new matrix L and U, and then after after you find L and U matrix, the new matrix, then we solve normally using Gauss elimination, the usual elimination linear algebra. Okay, can we see? Okay, so example, the step-by-step process. Okay, given you have matrix A and multiply with matrix X and you get matrix C. Okay, so A, normally you know the values of A. Okay, X is the one that you have to find, S1, S2, S3, right? And C is the right hand side matrix. Okay, so first we have to decompose, okay, like divide, okay, the matrix A into 2 matrices, lower and upper, L and U. Okay, the matrix will be 3 times 3. Okay, 3 in rows and 3 in columns. Okay, and then there's another 2 steps. Okay, when we have found the lower and upper triangular, we have to solve both of these matrix. Okay, for example, the first one, the lower matrix, okay, multiply with another matrix Z, we call Z. So there will be Z1, Z2, Z3. It will be equals to C. Okay, this C, this right hand side matrix. And then by using this matrix, we can find Z, matrix Z, Z1, Z2, Z3. Okay. only for the lower triangular side of the matrix A. Okay, and then another one, we have to solve the upper matrix. So Ux it will be equals to Z. Okay, and this is when we got the final answer X. Okay, so the rules is like that. Okay, imagine you have the lower and upper side of the matrix A, and then this each of this matrix lower and upper will be multiplied with unknowns values algebra, and that's how you solve the linear algebra in order to get the X. Okay, the unknowns. Okay, we'll see. Okay, this one is in the same thing, just that it in terms of like a flow chart. Okay, so but here they use another notation, but this the method, the step is the same. Okay, so imagine you have matrix A and X, and the right hand side is the matrix B. Okay, if you look at this, the notation, how you write the right notation for each for matrix, they are different, right? For matrix 3 times 3, or the square, we call it square 3 times 3 or 2 times 2 matrix, normally we will write it in a bracket like this. Okay, but for matrix like 1 times 3, okay, X and B, or S and C just now, the bracket will be like a parenthesis like this, bracket like this. Okay, so actually the notation is a bit different, but it's just for notation and definition. Okay, but as long as you understand what is 3 times 3 matrix, 1 times 3, okay, as long as you understand that, that's okay. Okay, so so this is the steps, but in terms of a flow chart like this. Okay, so you have matrix A and matrix X. So the right hand side will be matrix B. So from here, we have to decompose the matrix A in terms of upper and lower triangular matrix. Okay, like just now, right? We decompose first. And then this L, this matrix lower, okay, will be equal, will be multiplied with an unknown matrix, a new unknown matrix that we call D, or here we call Z, so it's the same, just notation. Okay, D will be equals to B here. So this step is also called forward substitution. Okay, forward and backward. Okay, so forward, the lower, we use the lower triangular matrix, so multiply with D, so equals to B, and that's D. We will get the answer D because we know L and we know B is given. So when once we get the achieve the values for D, D1, D2, D3, then this D will be used for backward, to solve the backward substitution using the U upper triangular matrix of A. Okay, U is the upper triangular matrix of A. So U times X, the actual unknowns that we want to solve. Okay, X. So B equal to D, so we will get the last answer, the X that we want to find, S1, S2, S3. Okay, so that is the steps. You have to remember a bit, it's like memorization. Okay, you have to remember the steps. So there are 3 steps: decompose, solve L, L for solve D or Z for lower, and solve X in the end for upper triangular matrix. Okay, so this is example. Decompose to L, not yet example, but just to show you how to write the decomposition. This is actually L, okay, because of this PowerPoint, the L doesn't come out. Okay, but this is L, L21, L31, L32. Okay, so you have so the lower matrix A will be written like this. So matrix A is 3 times 3, the same as L and U, 3 times 3. So when you decompose the matrix, the lower matrix will be like this, 1, 0, 0. This is the rule. So the identity matrix, this the diagonal matrix will be in identity 1, 1, 1. This is 0, and this value L21, L31, L32 that we have to find. Okay. And the upper matrix, we call it U, okay? So you have U11, U12, U3, U13, etc. And this three term will be 0. So it is the opposite of this one. Because when we multiply this and then we will get back A, the matrix A. Okay, so U is the same as the coefficient matrix at the end of the forward elimination step. Okay, this one, okay. And then L is obtained using the multipliers that were used in the forward elimination process. Okay, the definition is okay as long as you understand the lower and upper matrix. Okay. Okay, so example. Okay, example. So example, we have this is matrix A. Okay, we have 25, 5, 1, 64, 8, 1, 1, 4, 4, 12, and 1. Okay, so in order to decompose the matrix into decompose matrix A into L and U. Okay, so first we will do for we'll do for L first. Okay, we'll do for L first. Okay, this is an example. Later on, we will try to do one as exercise, not example exercise. Okay, this one I will show you the steps. Okay, so to find L, the lower matrix. Okay, so as usual, you use the Gauss elimination, like when you solve a linear algebra equation. So I think this one you are already familiar in maths one, I think. Okay, so this one example. We want to get we want to achieve 0, 0, 0 here. Okay, we want to find U first. Sorry, we want to find U first. So 0, 0, 0 here. So we have to rearrange, okay, the matrix A in order for this one, this component, this one, and this term will be 0. Okay, so we do step by step. Okay, so step 1, we want to achieve this one 0 first. So 64. How do we get from 64 to 0? So normally the simple one, we will look at the second row because 64 is in the second row. Okay, and we will plus or minus and multiply, divide or anything. Okay, calculation with the first row. Okay, normally we will do like this. Okay, there's maybe another method of calculation as long as you get 0 below here. Okay, so here example, the most common one. So we will divide 64 with the 25, the second row with the first row. Okay, and then we will get like the coefficient. Okay, which is 2.56. And we know that this value, this coefficient, if we multiply with the back with the first term, the first row, 25 here. Okay, then we will get 0 here. Okay, so row 2, for example. Okay, row 2, 64 minus 25 multiplies 2.56. Okay, so this is this term will be 0. Okay. As the rule for linear algebra, if we do change the calculation for the first term of the row, this is the row, second row, the first term of the row, then we have to change to do the same, to apply the same also for the rest of the component or the rest of the component throughout the row. Okay. So we have to do the same, we have to conduct the same calculation for this and this. Okay, even though this one and this one will not be 0, but we still have to solve. Okay, don't forget that. Okay, sometimes the students, they only do this one and then they, okay, next. Okay, they forgot to do the same calculation for the next term, the next component. Okay, because you have to imagine the matrix is actually, it's like, the matrix is always like a linear equation. Okay, so if you do calculation plus, minus, multiply, etc. for one term, then you have to do for the rest. Okay, like
sorry, doctor.
Yeah.
Some of the students are waiting to enter.
Itulah sebab lambat. So you can...
Sorry, doctor.
Okay, the rest you guys are late. That's why I didn't accept at first because a bit disturbing for me to change the window. Okay. Okay, 64. Okay, imagine that we have 64 x1 plus 8x2 plus x3, right? Okay. Something. Okay, so you have to imagine the matrix. It's like a linear equation. So if you do some, if you change the calculation for the first term, the first component, then you have to do for the rest. You cannot do just this one. Okay, so always remember that. Okay, so but the parameter, the coefficient, okay, the numbers will be the same. Okay, so you have we have achieved a 0 for 64 here. Okay, then you have to do the same for example 8, row 2 8. So 8 minus 5 row 1 multiply with 2.56. Okay, the only one that changed is the component for row 2 and row 1. Okay, this one, the 2.56 is like a coefficient. So you have to stay the same numbers, values for the rest of the row. Okay, so don't change this one. You don't need to divide 8 with 5. Okay. Okay, so that's how you get minus 4.8 and minus 1.56. Okay. And then for row 3, okay, in order to achieve from 144 to 144 to 0, so you do the same, okay, with the first row. Okay, so you do the same with the first row, you divide, you get 5.76, and then row 3 minus row 1. So all the component for row 3, 12, 1 also will be 12 minus 5 times 5.76, so you get minus 16.8. Okay, so the first row, the first column, okay, the first column for second row and third row, we have achieved a 0 value. Okay, for this one, so only 35. Okay, so that is step 1. Okay, and then step 2. Okay, so we need to find and we need to get this value 0. Okay. Okay, to get U matrix just now. So minus 60.8, so the same thing. Normally we will compare with the row above. Okay, so this one we choose minus 4.8. We can also do instead of with row 3 minus row 2, we can also do with row 3 minus row 1. Okay. Row 3 minus 16.8, so divide by minus 4.8, 3.5. Okay, so you get 0 here. So at last we achieve the matrix U with 0, 0, 0 value for here. Okay. Okay, so that is matrix U, and then matrix L. So L, okay, matrix L, the definition is like this. You have 1, 1, 1. In the diagonal. Okay, so you need to find these 3 values. Okay. So this is the matrix A just now. Okay, so here okay, we use, okay, the coefficient just now that we get from this one. Okay, 64 divided by 25. Okay, so this is actually will be the value of L21, and L31 is 144 divided by 25. The first row, the third row divided by the first row. Okay, so you get 5.76, the value just now, same value just now. Okay, so that is your L21, the component for L21, L31, and okay, the same for L32. Okay. Okay, so this is the matrix L. 1, 1, 1, 2.56, 5.76, and 3.5. Okay, so if you want to be confirmed, okay, of the calculation that you have done, whether you have correctly decomposed the matrix A in terms of lower and upper triangular matrix, then you multiply back. Okay, just multiply back and see whether you get the matrix A or not. Okay, for example, if we okay, we take the value 144 here. Okay. Mana tak? Oh, okay. 144 is here, right? Okay, the third row, first column. So third row, first column. Third row, first column. Okay. So you have to multiply 5.76 with 25. Okay. 5.76 with 25. You can do with your calculator. Okay, 5.76 multiplied with 25, you will get 144, right? Okay, so and then you do the same for other components. Okay, just to make sure that you have correctly decomposed the matrix A. Okay, but not yet finished. Okay, so if you choose this LU decomposition method, okay, this step is only the first step, which is the decompose matrix A into L and U, and then you have to do the forward substitution and backward substitution, solve the Z and X, right? Okay. So example here, solve the following set of linear equation using LU decomposition. So the matrix A just now. So here we are given the matrix on the right hand side, the matrix B or C, whatever you want to call it. Okay, so this is the LU that we have decomposed. Okay, L and U. Okay, the LU matrix that we have decomposed just now. So the first step was is to get the to use the forward substitution L. Okay, to get the matrix Z. Okay, so this is L, this is Z, this is C. So we copy back the matrix C. Okay, so multiply each component matrix. I hope you remember how to multiply a matrix with a matrix. Okay, so we have this one 3 times 3 matrix, and this one is 3 times 1 matrix. Okay. 3 times 1, okay, 3 times, okay. 3 times 1 matrix. So the answer will be 3 times 1. Okay, so the rules is like this: 3 times 3 multiply with 3 times 1. So we see this one 3 and 3, so means that the matrix, both of the matrix can be multiplied. Otherwise, we cannot multiply, right? If we don't have the same value here and here, and the answer will be in terms of matrix 3 times 1, which is the same as matrix C here. Okay, 3 times 1. That is the rule. Okay, so okay, the first line Z1, there is some errors. It's actually Z1 equals to 106.8. 106.8, not 10. 106.8. Z1. Okay, this is direct 106.8. So you have Z1 106.8. And because 1 multiply with Z1, and then 0 multiply with Z2, 0 with Z3, so 0. Second line means this one, second row. Okay, second row. So second row, first column. Okay, second row, first column. So second row 2.56 multiply with Z1 plus 1 multiply with times Z2 will be equals to 177.2. Okay, and the third row, first column, third row, first column. So third row, 5.76 Z1 plus 3.5 Z2 plus 1 times Z3, Z3. Okay, so we have 279.2. Okay, so this is easy. So since that we have already the answer for Z1 directly, 106.8. So we substitute the Z1 in here, so we get Z2, and substitute Z1 and Z2, and we get Z3. Okay, this is easy. Okay, so we have solve for Z. Okay, so this is the value of Z. 106.8, Z2 minus 96.21, Z3 0.735. Ada lagi masuk. Okay. 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 Set. Next step. Okay. The third step and the final step is to get the X. Okay, the unknowns that we are searching for. Okay, so this is the matrix, the upper triangular matrix of A just now. So we have 25, 51, etc. Right? This one that we have already achieved just now. This is the matrix X that we have to search. Okay, and will be equal to will be equal to Z. Okay, Z just now. Okay, Z, the one that we have solved previously. Okay, so the three equation, 25 times x1, whether you want to write a1 or you want to write x1, so it's correct. Okay, so 25 x1 plus 5 x2 plus x3 will be equal to 106.8. Okay, so this time you may get the answer for row 3 first. Just now, for L matrix, we achieve Z1 first, the first row first. This one, since it is upper triangular matrix, so we will get the answer for A3 or X3 first, okay? So this is the answer of X3. We divide this one and then replace X3 here, and then you get X2 and replace both of them here, in the first line, and you get X1 or A1, okay? So this is the calculation. So you get X3 1.05, X2 19.77, okay? And x1 0.29. So hence the solution vector or the matrix X is 0.29, 19.7, and 1.05. Okay. Okay. So that's it for LU decomposition. If you choose LU decomposition to solve a linear algebra equation. Okay, it's a bit long. It's actually the calculation is quite simple. It's just that you have to remember the steps. So which measures and then which measures to multiply which with what. Okay, so just to remember the steps. Otherwise, the calculation is quite direct. Okay. Okay. What else? This is an example if we have multiple rows and columns. So the process will be longer, okay, will be more difficult, okay, especially, of course, we cannot do by hand or manually. We have to use programming, okay, software. No, so, okay, every entry, okay, this is just repetition. Okay. I don't want this one, okay. That's next. Okay, always bring this one, okay. Okay, I think we already enter the topic for Gauss elimination here. Okay. Okay. So actually, the Gauss elimination, okay, this is the one that you are already familiar. So for example, we have linear system XYZ here. Okay. We just rewrite the system into matrix, and the difference that just now or normally generally we have 3 times 3 matrix. So here we include the Gauss elimination. We include the right hand side, the right hand side of the matrix of the value here into the matrix as well. Okay. So you have okay, so you have this sort of a matrix. So you just replace this linear system inside the matrix, and it's the same. Okay, you have to rearrange. You have to rearrange the each row in order to get zero values. Okay, below. Okay. So for example, this one, second row, okay, multiply with 1 plus plus row 2, and then we will get 0 here, okay. So actually -1 plus 1, so you get 0. So you do the rest for the row, and then the same thing for the row third row, okay. Okay, this one, and then okay, ini 952. Okay, wait, just now, this is the second thing, okay. Another, this is example, I think, okay. Okay, skip this one, okay. Okay, this is, okay, how you solve, example of how you solve the Gauss elimination with, when you have only one solution, okay. Okay. So, okay, this is the linear equation just now. Okay, so we try to get a 0 for row 2 and row 3, and then 0 for this component. Okay, and the rest. Okay, and from here we can solve directly. Okay, after getting all zeros here, so means this one is Z. Okay. So Z will be equals to 2. Okay, so this is quite simple. Okay, so we have Z 2, and replace Z here. This is X. Okay. Okay. So you have the matrix. So you just rewrite this matrix in terms of linear equation. So you have X minus 2Y. Plus 3Z equals to 9. The second one is Y plus 3Z equals to 5. And the third one, Z equals to 2. Okay? So you just convert the matrix in terms of, and write in terms of linear algebra. So you have 2 here, no, Z equals to 2. So replace the Z 2 here. So we have 6. 5 minus 6, we have, so you get Y equals to -1, and this one -1, 2, 2 plus 6, so 9 minus 8, so you get X equals to 1, okay? Okay, so that is how you solve a system by using Gauss elimination that only have one solution, means that X is always 1 despite whatever other parameters change or not, okay? So X is 1, Y is -1, and Z is 2. Okay, another example, where we have infinitely many solutions, okay? Means that the solution can be several, okay? So for example, it's like this. We have 3 unknowns, x1, x2, x3, or x, y, z, but we only have 2 linear algebra. Okay, I think this one is x2. Okay, 2x1 plus 4x2 minus 2x3, and 3x1 plus 5x2 equals to 1. Okay, so you rewrite the linear equation in terms of matrix: 2, 4, -2, 3, 5, 1. So don't forget the 0, even though we don't have the value s3 here, but when we rewrite it in terms of matrix, we have to put 0 here. Okay, and then we do the same, eliminates the row below to get a 0, and we have this type of matrix. So this matrix, if we rewrite it in terms of a linear equation, it will be x1 plus 5x3 equals to 2, x1 0, x2 minus x3 equals to -1. Okay, so here we can see that we have 3 unknowns, x1, x2, x3, but we only have 2 linear equation. Normally, we will have, if we have 3 unknowns, then we should have 3 linear equations. If we have 4 unknowns, then we have 4 linear equations. That's how you solve normally the mechanical problems, etc. Right? We try to find the same equation or relation with the same numbers as the unknowns that you want to find out. Okay, so but here we are a bit stuck. Okay, we only have two relation or two equation, linear equation, but we have three unknowns. Okay, values that we have to solve. So what do? Since we only have access to that information, so we have to write the answers something like this. Okay, the leading variable will be x1, x2, and the free variable will be x3. Meaning that x1 and x2 depends on the value of x3. Okay, so whatever the value of x3, as long as the condition or the boundary condition or whatever the rules still allow, okay, so we can choose any values of x3. Okay, so for that values of x3, then we will have the answers, the value of x1 and x2. Okay, we write like this, something like this. So the equation just now, okay, if you rewrite this equation in terms of x3, so we have x1 2 minus 5x3 and x2 minus 1 plus 3x3. Okay. Okay. So example, if you have if we assume x3 is equal to t and unknown t, anything t that is valid in real numbers. Okay. So x1 depends on t. So here we write it as 2 minus 5t and x2 minus 1 plus 3t. And x3 equals to t. Means that if we assume t, if we take t equals to 2, values 2, or negative 3 something, okay, 2 for example, so x1 will be 2 minus 10, so negative 8, and this one will be, x2 will be minus 1 plus 6, 5, okay? So x1 will be 8 and x1 will be negative 8 and x2 will be 5. So it depends on the value of x3. Okay, so that's why we said we will conclude the answer if we encounter problems like this. Okay, so we will conclude that x1 and x2 depends depending on value s3 for all number, for example, contains in real numbers or natural number or something like that. It depends on the questions. Okay, what is the boundary condition or the rules? Okay, normally it's in real values, means any numbers can we can take any numbers. Okay. Okay, so this system has infinitely many solutions. We said that this system has infinitely many solutions. So because we whatever value of S3 is valid. Okay, I think this is the last slide. Okay, but okay, I will give you example. Okay, we try to do some calculation a bit. Okay, example, I try to write. Okay, wait. Give me 1 minute, okay? Okay, one problem for Gauss elimination. Just now we have this one, 9-4. Okay, we'll take this one. I just add new slide. Okay, so we have, okay, I write this in equation 3x. Okay. So 3x plus and minus 0.1 y, okay, minus 0.2 z equals to 7.85. Okay, so this is the first linear equation. Second line, 0.1x plus 7y minus 0.3z. Ada lagi yang nak masuk? Okay, equals to minus 19.3. Okay, and the third line 0.3x minus 0.2y plus 10z equals to 71.4. Okay. So by using Gauss elimination, okay, try to solve this linear algebra equation, okay? Try to do this one. Let me put example. Okay?
Okay, doctor.
So 3x minus 0.1y minus 0.2z equals to 7.85, 0.1x plus 7y minus 0.3z equals to minus 19.3, 0.3x, 0.2y, 10z equals to 71.4. Okay? Try to do this.
Dr. Gauss elimination.
Sorry?
Do Gauss elimination or LU decomposition?
Use the Gauss elimination because it's more faster.
Okay.
So for this linear algebra equation, you will get only one solution. Okay, so we have x1 equals to what? Yeah. But I didn't receive any notification. Saya tak ada dapat apa tu application apply untuk masuk pun. Kalau tidak suruh dia apply semula, I mean go out and try to click again. Kita terlepas. Okay, done. Haikal. Okay, Haikal, we are doing example, okay, on the screen. Try to solve the example. Does anyone have achieved at least we will get the answer for x3 first. Okay, by using Gauss elimination, you will get the answer for x3 first and then substitute x3 in the second line and then first line. So x3, anyone get the answer x3? Ada yang dah dapat x3? Hello?
He's still trying, Doctor.
Okay.
Just a bit more time.
Okay. Boleh betul, okay. Yeah, alright. Okay.
Doctor, I got 7.0898.
Yes, 7.0898 for x3, right?
Yes.
Okay. Kita continue for x2. Can you mute your mic?
Oh.
Okay. Thank you. Apa yang saya tulis ni? So if you, okay, let's take just now. Okay, you have the first line 3 minus 0.1 minus 0.2 equals to 7.85. So if we, this is 0, okay, we try to get 0 row 2 here. So we will get x2 7.003 x2 and x3 minus 0.293 x3 equals to minus 19.5 or something. At least you get a close value to that. It's okay. Okay, maybe it's not the same exact values. Okay, depends on your the coefficient that you choose. Okay, and then the third row, this one. Okay, so this is 0, 0. You get 10.012 x3 equals to 70.08. Okay, at least you can write to 3 to 4 digits after the decimal. Okay, but I don't have enough place. Okay, write 70.0843 or etc. Okay, so this one, so you get this is the linear or the matrix that you will get when you eliminate, okay, this one, and this one. Okay, so for x3, 70 divided by 10, so you get x3 around 7. Okay, like just now Kishore, he got 7.0 something, right? 0.58 or something like that. So it's okay. Okay, if you don't mind, it's 7 tepat. Okay, 7 pil. Okay, so at least you get something close near to 7. Okay, maybe you get 7.020. Okay, so x3 is 7. So then just substitute x3 in here and here. Okay, and then you get S2 and then X1. Okay, try to finish that. So what is X2 and what is X1?
So I got x2 is negative 2.5.
X2
Yes.
2.5.
Negative
Okay.
2.5.
Okay.
Negative 2.5106.
Okay, it's okay. Negative 2.5 around that. Okay. Okay, thank you, Lim Jo Hin and Kishore.
X3 I got 9.016.
For what? For X1?
X1 9.0169.
I think there's some error for X1. X1. Okay, so
I
just
get 3.
yes, 3. Okay, maybe you did some error in the calculation, but because your S3 and S2 are correct. So x3 is 7, around 7. Okay, so if you guys got something along that line, so okay, even though 7.00 or 6.999, etc. X2 is minus 2.5. Okay, minus 2.5, and x1 is 3. Okay, so if you get 2.99, so correct. Okay.
Yes, I got to divide 3.
Okay. So just now you solve x3 around 7, x2 around minus 2.5, and x1 3. Okay, this is by using Gauss elimination. Everyone okay? Because only 2-3 people speak to me.
Yes.
So I want to know if the rest of you okay. Can you catch up?
Sure. I might have made some mistakes in the middle, so
Of
my
calculation?
final answers are not matching with the others.
Or you got the totally different, totally
No, doctor, my Z matches, but I might have made some mistakes while calculating inside, so my Y
Oh.
and X are different.
okay, sorry. Just now I use XYZ kan? Okay, sorry. XYZ. Okay. Okay, XYZ. Okay, just look back, okay? Verify back your calculation. Maybe just some error in the calculation, okay?
Okay, doctor.
Okay, others. Azril, okay? Yang tidur ke? Ridwan, Faiz, Sabrina. Izati, okay? Tadi belum, sekarang dah okay? Right now, okay?
Tengah kecap doktor. Sabar.
Tengah kira lagi? Okay, okay, Miss Aida. So okay. Actually the approach is simple. It's just that we tend to sometimes do error because banyak sangat calculation. There's a lot of calculation to do. So sometimes we do some mistakes the calculation. Okay, so please verify that and take a look closely. Okay, on your calculation. Okay. Otherwise, I hope you guys understand the method, okay? Everyone understand the approach, the method. It's just that error in calculation. Okay. Next, okay. This one more example. Okay. Before we finish, okay. The same questions, the same linear algebra question. We try to use the LU decomposition method. Okay. But we will do only the decomposition part because we already know the answer, the X or XYZ, right? We already know the answers. Just we want to do to see how we decompose the matrix A. So take back this matrix, okay? So example, this is matrix A, 3 minus 0.1 minus 0.2, 0.17, 0.3, 0.3 minus 0.2 and plus 10. Okay, this is the matrix A. And then you have the matrix X, XYZ. And your matrix C is 7.85 minus 19.3 and 71.4. Okay, so we will only try to do the first step, decomposition of matrix A in terms of lower and upper triangular matrix. So try to decompose matrix A in terms of L and U. Matrix L and matrix U. Later on, I will ask what is your matrix L and U. I will not ask the solution X, Y, Z anymore because we don't know that. So we just want to know the LU decomposition. Okay, so for those of you who came in late just now, actually before I explain the Gauss elimination method, we have gone through the first method, which is LU decomposition. Okay, so the definition, LU can be the matrix A. Okay, the matrix A can be decomposed in terms of lower and upper triangular matrix that we call L and U, matrix L and matrix U. So we have this matrix L and this matrix U. So we have to decompose A, okay? We have to find the value for each component. U11, U12, U13, U22, U23, U33, U33, and this one, L21, L31, and L32. Okay, I'm asking you to find this L and U. Okay, no need to find until X. You can do by yourself, but you already know the answer. Just want to find L and U. Okay, so normally we will find, we try to search for U first. Okay, so the steps to search for U is actually, the calculation is like the Gauss elimination calculation as well. So row 2 divide minus row 1, multiply, etc. Because we want to eliminate the row, okay, the second and third row. So you get U just now. This was the example just now given. So for L, we will use the coefficient that we get. Okay, L. Okay, and then we get LU. Okay, so that was the step. Back to the question just now. Okay, so what is L and what is U? And then try to multiply back and see whether you get back or not the matrix A, the initial matrix A. If you want to see to verify whether your method calculation is correct. Sorry, this L, not you. What? Oh, you gave the answer. Okay. Wait, pening sikit. This is L, not you. Okay, so that means the one that you give is L. 0.03, 0.1, minus 0. Your wait, I respond to Kishore first. For your L, this one, L, what is it called? L32, your L32 is minus 0.1286 is a bit different than mine, okay? Otherwise, the L21, L31 is correct. Okay. M lim U. Okay, this is the limbs U. Okay, correct. For you, for you is correct. For L to the L2 L32 L32 to calculate back. Verify back. The minus 0.1286. So. Okay, correct, Lim. Okay, so the answer is is written here by the help of Kishore and Lim. Okay, thank you. But we try to help others as well. Okay, the others, if you guys have any problem or you stuck, you can just ask. Okay, I understand it is a bit to digest the new thing. Okay. So for Lim and Kishore, if you want to verify back your answer, try to multiply back L and U, and did you get A?
After the L23, right? Or 32, L32.
Apa? Sorry.
The L32,
Uh-huh.
I actually got negative 0.1285. That's the answer I got.
Sorry, I couldn't. But the answer is actually negative negative 0.027, like the one that Lim have written here.
Oh, but
The L32.
oh, wait a minute.
Okay, so if you multiply back your answer L and U, actually you won't get the exact the same A as initial, but it is the values is approach is very close to the actual the initial A, but not the same as that. For example, just now you have this is 10Z. Now if you after you decompose and you multiply back, you will get 9.999 something. So, but just to say that your decomposition is correct. Okay, it's just that after the composition, the real matrix may change a bit, but it's still the same matrix. Okay, so you will get LU if we multiply that. 3 minus 0.1, 3 minus 0.1 minus 0.2. This is the same. This one 0.099999. Okay. 7 0 0.3 0.2 0.3 here minus 0.2 and this one 9.9999. Something like that. Okay. So okay. You see 3 minus 0.1 minus 0.2 still the same. So 0.1 now you get 0.099999. 7 minus 0.3, 0.3 minus 0.2, and 9.9999. Okay. So your A, your decomposition of A is verified. Okay. So your LU is correct. Okay. I think that's all. But you can proceed by your own self, okay? If you want to solve the same the question, the example just now, the linear algebra question, finish the LU decomposition method, okay? So you have to find okay, you find X and you find the Z, okay? Z and X, okay? And in the end, you'll get the X, the same as just now, 3 minus 2.5 and maybe 7.00 something. Okay, but it's closely the same as the Gauss eliminations now. Okay. Okay, everyone. Any question?
Yes. No.
Okay. Okay, if not, then I'll give you attendance. Please. Mana tah? Wait, oh, okay. Sekejap. Okay, so we have 57 right now. Okay, so 50. I wait until 57 has represented the attendance. Okay, so please fill in the attendance for this week. Okay, everyone okay tak? Adrian Hardy okay. Syahrul Azri. Okay, Adrian, I have received your assignment just now. Okay, just received just before the class started. Okay, the rest of you can continue submit your assignment. Okay. Yeah, they left meeting dah. Okay. Otherwise, I don't have any more any more slides or anything. Okay. So if you have fill in the registration attendance form, you may leave. Okay. Thank you.
Doctor, can I ask about the assignment?
Okay.
Because my group did like for MATLAB and Python, and the MATLAB I use the trial version 1, so we only can able to use on the website. So I cannot save it on my as a file in my laptop. But then if we want to submit, I'm not sure if you can access it. So how do you want us to just copy the coding into a Word and then just send PDF? Can
You mean the coding you tak boleh nak save? Just copy the coding in Words or in Pad, Notepad, and save the file.
But because we run it on the website boleh je. Tapi just tak boleh save
Oh,
lah.
pakai MATLAB website saya tak tahu.
Sebab trial version kau tidak kena bayar mahal.
Oh, okay. Python tak boleh? Tapi dah
Python boleh je. Python tapi yang version MATLAB punya. Kita orang buat dua-dua version.
Oh, okay. Just now kalau copy tu boleh? Tadi copy kepada Word tu.
Boleh. Copy coding dia je. Kan?
Lepas tu record video tu lah.
Dah. Okay. Saya hantar yang tu. Okay. Terima kasih.
Okay. Thank you everyone. Sabrina. Ya?
Assignment tu kena hantar by group ke ataupun individu?
Seorang hantar, patutnya CC lah kat kawan-kawan, tapi banyak yang hantar seorang-seorang macam tu je, tak apalah. Tapi just list down your friends name lah, sebab ada yang tak list down kan.
Okay, thank you Doctor.
Okay.
Doctor,
Yes.
our test one will be in week 6. Can you kindly tell us which chapters should we emphasize for the test? Do we have to write codes in the test or just do calculation like this one on our note, Doctor?
Okay. For test there will be in 2 weeks, huh? Okay, 2 weeks already. Okay, in 2 weeks. The test will be, of course, chapter 1 and chapter 2 next week. Okay, chapter 2 is smaller than the chapter 1. Okay, it's mainly on the calculation, no coding.
Okay, Doctor.
No programming or any written code. Just like example exercise calculation.
Okay, Doctor. Thank you, Doctor.
Okay.
Doctor.